Hello, welcome back to a crash course in circuit theory. In this lesson, I will talk about the driver subsystem theory. The microcontroller that you see in front of you is currently being used to turn an LED on or off. This is perfectly okay because the LED is a low current device and the voltage requirements for the LED is below the 5-volt power supply that's used by the microcontroller. However, there are other components that we use the microcontroller for controlling, such as motors, buzzers, lamps, heaters, relays. These are all high current devices. What that means is that these devices typically need anywhere from 100 milliamps up to 1 amp of current. Now, our power supply here is more than capable of providing power to these devices. However, since we are using the microcontroller as a control unit to switch the devices on and off, if this current passes through the microcontroller, there are limitations. There are some very sensitive circuits inside the microcontroller, and as you know, the microcontroller is a very small component, and if too much current passes through the microcontroller, then it will become too hot and it will burn. Which is why we need to add another level or another layer of circuitry in our design, and we call that the driver subsystem. The driver subsystem. This is a block diagram of a typical driver subsystem, which consists of the digital controller, which in our case is the microcontroller. Some microcontrollers have a built-in digital to analog converter inside. But right now we're just going to talk about straight digital control, and we'll move on to analog control in more advanced lessons. Since we have concluded that we cannot connect a high current device directly to the microcontroller, that means we must add some additional circuitry to operate this final control element, or your final load. We do this by adding a driver circuit. Here's the basic theory, or here's a basic driver circuit that we use. Is very common. It's called a transistor driver. The idea behind the transistor driver is simple. Use the transistor as a current gain device, and using the transistor as a current gain device, we're allowed to take a small current and use it to control a much larger current. And the current limit is dependent upon the capacity of the transistor. Now, you may not have used the transistor in exactly this way. Most of the time, you have used the transistor as an amplifier in your electronic circuits classes. And perhaps in your microcontroller class, you have been using this, but you focus mainly on the programming part. But there's another use for the transistor, and that is a digital switch. A digital switch. When we say digital switch, what we mean is that it will switch on and off in two positions, just like a regular switch. As far as the transistor is concerned, there are three positions. We call it cutoff, we call it active, and of course, we have the saturation. You learned this in your electronic circuits class, but you focus mainly on the active region, which means your goal was to set the transistor in a position so it can receive AC signals without moving into the cutoff or the saturation region. But now we're actually going to use the cutoff and the saturation region to function as a switch. In the next video, I will explain how this actually works.